Hello and welcome to the test take-up for the second test for 2x03, 2G03. This is winter semester, January through April 2013. I've got sort of the first four questions here, which are what I'm going to do in this first video. I'm going to do the last four questions in the next video, just to make it easier to kind of find things. So anyways, the first question is, any firm producing in a particular competitive market has long-run cost of production, TC equals y cubed minus 20y squared plus 120y. Demand for the good is Q equals 500 minus 5p. In the long run, what is the price? How many firms are in operation? Okay, questions 2 through 4 all deal with the same demand and supply function. Demand 300 minus 10p and supply 5 times p. What are the price, quantity, consumer surplus, producer surplus, and deadweight loss of the following scenarios? Government imposes a $6 per unit subsidy. Government imposes a 30% tax. And they impose a price ceiling of $10. Okay, so if you wrote the test, then just follow me through the answers, or whichever ones you want to. If you have not written this test and are just using this for practice, then pause the video, practice the questions, and we'll come back and do the answers. Okay, so I've already kind of started here. TC is, well, it's all from the question. So the first thing we want to find is they're going to produce at the minimum value of average cost. So to find the average cost, first we're going to divide by y. Okay, then we're going to take the minimum value. And to take a minimum, we just take the differential with respect to y. Okay, and since we're finding a minimum, remember, always know why you're setting something equal to 0. 2y minus 20 equals 0. 2y equals 20. Y equals 10. Okay, and we also have perfectly competitive, so nobody's going to earn profits. So this minimum value of average cost is going to equal the price. Okay, so we'll plug this 10 back into the average cost. So average cost min 10 squared minus 20 times 10 plus 120 is 100 minus 200 plus 120 is simply 20. So P is $20. And quantity per firm is 10. Okay, so when we're answering the question of how many firms, we'd find out how much the market demands at $20 of price, and we're going to have to divide that by the number of units per firm. Okay, so quantity is 500 minus 5 times 20. So they're demanding 400 units. Right, so 400 is the number of units. Units per firm is just the total number of units. Sorry, we want number of firms. That's why these units aren't working out. So number of firms is 400 units demanded divided by 10 units per firm. Okay, so units over firms is just firms if you're doing the unit analysis. So, and 400 divided by 10 is just 40. Okay, and that's how we solve question 1. Moving on to question 2, I'm going to start with just a competitive equilibrium so we have something to compare to, and I'm going to look at all the subsequent changes to the market from there. So I haven't done any of these. Well, I guess I wrote the answer key for this test, but I haven't got it with me. Someone else is marking, so they're using it. So these are all by somewhat by memory, also by just doing them in front of you, so bear with me on some timing. So this is to start with, this is just competitive. And in academia, we like to call it a benchmark, meaning with no distortions. So 5p equals 300 minus 10p, 15p equals 300. So p, oh, sorry, I'm just actually doing this on the calculator. I know it's 20, but I don't want to make any mistakes. So the price is 20, which means that Q is 5 times 20 is 100. Okay, so to get the producer surplus, we're going to have 20 minus 0 times 100 divided by 2. So PS equals 20 minus 0, right? Because at quantity 0, price has to be 0. Right, and it's just a triangle. I'm not going to bother with the graph for this one because they should be pretty familiar. I will do a graph for the rest of them. PS looks like price supplies, but it's producer surplus. And then here is going to be consumer surplus. And we have to put this into just a quick inverse market demand. So I'm going to take the 10 over here, move the Q over here. So it's going to be 30 minus 1 over 10Q. So my price maximum willingness to pay, my y-intercept is 30. Okay. And that means that this is 5 times 100, it's 500. Okay. So that means that total surplus is 1500. And since it's the perfectly competitive no distortion benchmark, deadweight loss is 0. Okay. So now we're going to go in and do the $6 per unit subsidy. So basically that means that we're introducing some sort of incentive to buy this product because we're basically reducing the price by $6 for every unit that you buy. Sorry, I'm just trying to get some kind of a ruler onto this thing so I can draw this graph with some semblance of adequacy. So I've got a demand curve, I've got a supply curve. Now I've chosen to impose, I mean I can choose what I want to do, whether I want to give a $6 subsidy to the producers or whether I want to give a $6 subsidy to the consumers. Doesn't really matter. Basically what I want to do is shift one of these two curves by the amount of the subsidy. Okay, so what I'm going to do is I'm going to move this up a little bit. Okay, so basically the difference here is $6. $6 so that PD minus, well, PD with the subsidy minus 6 is actually the real price of demanders, right? So basically I've shifted their demand schedule up for any possible quantity, right? So this being P and this being Q, right? So I need a basic relationship to come up with the difference in between price of demand and price of supply, right? Because I've driven this wedge in here, and I need one equation, because I only have two equations, so I need to find some third equation to relate price of demand to price of supply, okay? So PD minus 6 plus 6 is going to equal PS. Okay, and now I want to plug this equation into my demand equation. So QD is now going to be 300 minus 10, right? And instead of, sorry, I did PS, so QS. I'm going to plug this expression for PS in instead of the original expression that I had. So 5 PD plus 6. Okay. So now I can set these two things equal because the new equilibrium is going to work because I have PD and PD. I don't have 4 unknowns. So 5 PD, and I'm just going to separate this out, plus 30 equals 300 minus 10 PD. So I still have 15 PD equals now 270. And market quantity is 18. Sorry, my price is 18. Which means that market quantity, PD is 18, sorry, which means that market quantity is 300 minus 10 times 18 minus 180. Okay, so my new quantity is 120. Okay, and if 18 is PD, then we know that PD plus 6 equals PS, so PS is 24. Conversely, you know that you need to supply 120 units, so 120 divided by 5 is 24. Okay, so now we've got our new equilibrium here. All right, we've got this being supplied, this being demanded, and this is our $6 subsidy. So deadweight loss, of course, is this triangle, but I want to actually show you how you get that, aside from just knowing that it's that triangle. So we're going to go through the whole route of producer surplus, consumer surplus, deadweight loss, which you kind of had to do for the question anyways. So the producer surplus is simply, right, price of 0, price of 24 times the difference, right? So the quantity is 120 times 24 minus 0 divided by 2. Okay, and that producer surplus, and it should be 1440. Yes, it is. Okay. And consumer surplus is going to be similar, right? Their maximum willingness to pay is still 30 from before, and we'll carry that through all the way through the questions. I'm not going to reinvent the wheel here. Divided by 2 times 120 is 720. Okay, so consumer surplus has gone up and producer surplus has gone up, but we don't live in a vacuum, so we have to pay for this somehow. What are we paying? We're paying $6 per unit. So cost of I can't write cost of subsidy because that abbreviates to CS. So let's just put cost equals 6, which is the number of dollars, times the number of units that we're subsidizing. Okay, so 6 times 120 should be 720. Yep. Okay, so that makes the subtraction pretty simple. So we've got 1440 as a producer surplus, we've got 720 as a consumer surplus, and if we add all that together and then subtract this cost of implementing the subsidy, we get the deadweight loss, which turns out, well, we get the total surplus, right, which is 1440. Right, so that's just PS plus CS minus cost. Okay, and we're just going to take the difference in between the benchmark total surplus and this total surplus, and that's going to be our deadweight loss. So DWL equals TS, let's call this TS star for the rest of these questions. TS star minus TS, and the deadweight loss is then 1500 minus 1440 is 60. Okay, so that's the first part of this question. I'm going to save these numbers, the 500 CS, the 1500 TS, and the price and quantity of 120 for the later questions when I can't refer back to what I've done, because I'll be on a different page as soon as I find my pen. Okay. Question 3 is a 30% tax on consumers. Okay, so to set up a sort of equality, PD, right, equals 1 plus tau times PS. So PD equals, if this is 30%, then it's 1.3 PS, and that shouldn't really cause you any trouble. Okay, so what does that look like? Well, if I get my quote-unquote ruler back, I'm really cutting into my space to do this question, but hopefully I can kind of straighten that out a little bit. Okay, so I've got original quantity demanded, I've got original price on the supplier. So instead, right, if 1.3 times the price of the supplier is the price of the demander, then based on how little the price of the supplier is, I did this backwards, how little the price of the supplier is, the quantity demanded, and the price of the demander has to be smaller. So let me try to explain that better. So here where P equals 0, right, 1.3 times 0 is still just 0. So this point on the axis here is where they're equal. Okay, as I increase price, right, 1.3 times price becomes a larger and larger number until eventually, I mean, I can work this out, right, because I know that this is 30 if this is the original demand curve. So 30 divided by 1.3 is this number right there. Turns out it's not very important. We'll get our deadweight loss anyhow. So let's actually solve this out. Subbing in PD where we can. So QD is 300 minus 10, and instead of PD and PS, I'm going to substitute in this expression for PD. And then PD, or sorry, not PD, QS. Completely wrong. Is just 5 PS. Okay, so I can see that this is just going to turn into 10 minus, or sorry, 300 minus 13 PS, which I can see it's just, right, this is changing the slope of this, where if I flip these axes around, this line would be steeper than this line, which is exactly what we'd expect from this formula here. Okay, so QS equals 5 PS and QD equals 300 minus 10. I'm going to put that into 13 when I rewrite this here. So 300 minus 13 PS, then 18 PS equals 300. Okay, so then 300 divided by 18, PS is 16 and 2/3. I had a lot of you on this test just round up and down all over the place. Some of you took that last video I said where I was kind of complaining about having thousands of decimal places, a little too literally. I would like some decimal places. Best is if you give me a fraction. Fractions are great because they're as precise or imprecise as I want them to be based on, how significant I consider them to be. So then if PS is 16 and 2/3, then PD is 1.3 times 16 and 2/3 is 21 and 2/3. Okay, well I guess it wasn't this question where I got all kinds of weird rounding, it was the Monopoly question where I got all kinds of weird rounding. Okay, so PD is 21 and 2/3, PS is 16 and 2/3, so from that we can come up with some market quantity. Again, easier to use the producer price and just multiply it by 5. Okay, so it's 83 and a third. Okay, so what's our deadweight loss from taxation? Well, it's this area right here. But again, I want to go through and actually show, some kind of real deadweight loss in the sense that I'm going to calculate it all out based on surpluses. So I've got this price of the demand of 21 and 2/3, so I'm going to use that to calculate the demand side. So this is consumer surplus is 30 minus 21 2/3, right? Times the quantity, which is 83 and 1/3, all over 2. Okay, so my consumer surplus works out to be 361.1. My producer surplus is 16 and 2/3, right? The price they get minus 0 times the quantity, still 83 and a third, divided by 2. So I'll just work that out. And I get about 694.4. Alright, but I also have some tax revenue to account for. I have 83 and a third. 83 and a third units being taxed at the difference in between the price of the demander and the price of the supplier. So times $5. And for that I get 416 and 2/3. Okay, so adding all these up will give me my total surplus, and then I can subtract it from my benchmark surplus, and that'll give me my deadweight loss. So total surplus is 361.1 plus 694.4 plus 416 and 2/3. Okay, so my total surplus is 1472.2. And if my original total surplus was 1500, then my deadweight loss is the difference. Or 27.8. Okay, so that's how to do question number 3. Question number 4, we impose a price ceiling. So this is one where a lot of you will have given us a number when we wanted a range. Because when you distort the market in this way, you don't actually know who's going to get the units. Okay? So I put a hard price ceiling of 10. Um, that's a straight line, but since we know that the market price was greater than 10, we know that the price ceiling is binding, so there is actually going to be a restriction on the quantity. What that restriction is, we can figure out because we have the supply curve. But we don't know. What we don't know is who's going to get the number of units, whether it's the people who value it the least down here on the right side, or the people who value it most up here on the left side. So to figure it out, let's start out with what is the quantity. Well, the quantity supplied under the price ceiling is just going to be 5 times the price ceiling, since we said it was binding. Okay, so we have 50 units to divvy up amongst whoever's going to get them. So our best case, oh, incidentally, that's our market price and quantity is 10 and 50. So the best case scenario is that these people get it right in their best case, and the worst case scenario is this other one, which there's too much going on for me to write it in, but I'll just shade it in here. Okay, so to do this, we need this Q. We need this quantity at price of 10, and we need this price right there. So the worst case scenario is going to be the quantity at a price of 10, which is 200. And then if we have 50 units, then we need the price at 150. So the difference in the quantity, the base of the triangle is going to be 50. Okay, the difference in price is given to us by this P star minus 10. So if I plug in Q equals 150, you can see that this is going to work out kind of nicely. And it's going to be price of 15. Okay, so the base of the triangle is 50. The height of the triangle is 5, right? That 15 minus 10. And we're going to divide it by 2. So our worst case CS, consumer surplus, is 125. Okay, so incidentally, a little cheater trick you can use on the final if you're crunched for time on one of these questions is that this triangle of the worst case scenario is going to be the same as this triangle area on the best case scenario, and that is because your demand function is linear. So if you get a nonlinear demand function ever, which you won't on the exam, but you might in real life, you can't use this trick, but for now, we know that best case CS is going to be 50, sorry, I don't need to do that, right? I just told you I don't need to do that. So it's the area of the triangle, 125, plus this rectangle here where it's still labeled best case, right? So it's 50 is the base of the rectangle, and then the height of the rectangle can be given by our difference in price, right? We said the price height here was 5 in the worst case scenario, so it's still going to be 5 in the best case. Minus 10. $750. So I make that to be 875 is our best case consumer surplus. And then we just need to work out the producer surplus, which is 10 minus 0 times 50 divided by 2 is just 250. Okay, so we have a best case deadweight loss, producer surplus, plus consumer surplus gives us total surplus of 1125. And if we subtract that from the 1500 in our benchmark case, we get 375. And our worst case is a consumer surplus of 125 and a producer surplus of 250. And a deadweight loss of 1125. Okay, so I'll make another video with the answers to the last 4 questions in a few minutes.